Okay, good afternoon. This would be lesson number 6 for 11th grade. Okay, we're going to start talking about probability. Okay, we have been talking about statistics. Okay, and now we're going to start talking about probability. Okay, this topic you can find it on page 109. And remember that under each link you'll find some exercises that you need to hand in. Okay, we will start checking those exercises this upcoming week, so make sure to have them at hand. Okay, now when we're talking about probability, okay, we're talking about the chances of one event, okay, to happen. Okay, so we can use it in percentages. We can also use it in specific numbers. Okay, like the odds. Okay, odds are how many chances do we have to get any specific result. Okay, so when we're talking about probability, we have two very important definitions. Okay, they are the fundamental counting principle and mutually exclusive events. Okay, when we're talking about the fundamental counting principle, okay, here we have the definition. It says if one selection can be made in an m number of ways, m being a variable, okay, expressing how many number of ways can we have an event that is going to happen, and for each of these selections in the m number of ways, we have a second selection that can be made in an n number of ways. Okay, so the formula that comes from fundamental counting principle is that we have to multiply the number of chances that we have of one result times the number that we have for a second result. Okay, and this is just an example of two events. Okay, we might have 3 or 4 different events happening at the same time, and we will just apply this formula, which would be m times n, and if we have more options, then we would just need to multiply. Okay, with this example on the right, it's going to be a little bit more clear. Okay, now for mutually exclusive events, that's different. It says if one selection can be made in m number of ways and another mutually exclusive selection can be made in an n number of ways, then we have to add them. Okay, when we're talking about mutually exclusive, that means that one of these options is not included. Okay, with the examples, it's going to get a little bit more clear. Okay, now let's talk about the first one, fundamental counting principle. Okay, here on the right, we have an example. Okay, it says a new car has come into the market. Okay, so we're talking about a new car. Okay, it comes in 3 different colors, white, red, and blue. It has 2 types of engines, a 4-cylinder engine and a 6-cylinder engine. Okay, it has 2 types of transmissions. It can be manual transmission or automatic transmission. And also, it comes with 4 types of radios. Okay, it can have a stereo. Stereo means that it can only take radio, AM and FM. Okay, so a stereo with a 4-speaker, okay, a stereo with a 6-speaker, okay, a CD player with 4 speakers, and a CD player with 6 speakers. Okay, now, since we have all of these types of options, okay, 3 colors, 2 types of engines, 2 types of transmissions, okay, 4 types of radios. Okay, so we have the question, how many different combinations can we have? Okay, so in this case, we're talking about the fundamental counting principle. Okay, the difference here is that we have 4 different options. Instead of just having m and n, we have m and p and q. Okay, which would be m, the colors, white, red, and blue. We have n, which would be how many cylinders, 4 and 6, that means 2 options. Okay, 2 types of transmissions, manual and automatic, okay, 2. Okay, and the radio, which would be 4 options. Okay, so we have 4 different ways into counting the combinations for this car. Okay, so let's start to work on fundamental counting principle. Okay, so in this case, we would have m times n, which would be color and type of engine, but we would also have times p times q, because p would be the transmission and q would be the radio options. Now let's think about it. Okay, if the fundamental counting principle tells us, okay, that if one selection can be made in an m number of ways, and for each of these selections, we have a second selection. So that means that when we're talking about a white car, okay, we have this selection, but we also have a second selection, which would be a white, but it can also be 4-cylinder, or it can be white with a 6-cylinder. Okay, then we can have a red with 4 and a red with 6. Okay, then we can have a blue car with 4 cylinders, and we can have a blue with 6. But we can also have white and 4-cylinder, but manual. But we can also have white 4-cylinder and automatic. Okay, so when we're talking about probability, that's why we multiply the options. Okay, because that means that we're going to get the total number of combinations. Okay, so let's think about it. So if we have m times n times p times 4, what we have to choose is how many options do we have. Okay, how many options for colors? Let's put it here. For colors, how many options? 3, right? White, red, and blue. Let's talk about engine. Engine. How many options do we have for engines? 2. A 4-cylinder and a 6-cylinder. Okay? What happens with transmission? Okay, transmission. How many options? 2. Okay? And for radio, let me put it here on the side. For radio, how many options do we have? 4. Okay? So we have 3 options for colors, white, red, and blue. We have 2 options for engines, 4-cylinder and a 6-cylinder. We have 2 types of transmissions, 2, automatic and manual. And we have 4 different combinations for radio, which would be stereo 4-speaker, stereo 6-speaker, CD for 4-speaker, and CD for 6-speaker. Okay? So using the fundamental counting principle, all we have to do is multiply the options. Okay? So we would have a multiplication of 3 times 2 times 2, times 4. Okay? So if we take this and we actually solve for this multiplication, we're going to have the total number of combinations. So we have 3 times 2 is 6, 6 times 2 is 12, and 12 times 4 is 48. Oh, sorry. Okay, let's do it correct. Okay, so we have a total number of 48 different types of combinations. Okay, because we can have a white car with 4-cylinder and a manual and a 4-speaker. Then we can have a white with a 6-cylinder with also manual with 4 speakers. We can also have a white with 4, okay, automatic and 6 speakers. So every combination is counted. Okay, so when we multiply the number of options that we have for each event, then we have the total number of combinations. So between these characteristics, 3 colors, 2 types of engines, 2 types of transmissions, and 4 types of radio, we can have 48 different kinds of combinations for this new car. Okay, so that means that we can have it in red, with automatic, with a 6-cylinder, and with a CD with 6 speakers. Okay, so when we count all of these combinations, if we were to do it manually, we can have an exercise for an hour. But using the fundamental counting principle, we just multiply the number of selections that we have for an event, and we have the total number of combinations. Okay? So this is an example of fundamental counting principle. Okay, so make sure to check out these definitions. We have an exercise on page 109 if you want to go ahead and resolve it. Also, you'll have a link on the second video for this lesson. Okay, on the next lesson, we're going to work only on exercises, and you will have some exercises to solve for yourselves. Okay, so make sure to check them out, and if you have any questions, please let me know.